Hi everyone. So in this video we are going to look at another advantage of Clojure, which is encapsulation, right? So before we dive into encapsulation, let's first recap what a Clojure is. So let me scroll up. Okay, so this is a Clojure. Let me copy and paste it down below. So Clojure is nothing but a function which has some variables and an inner function which is bound to these variables, right? So inner functions accessing these variables, that means it is bound to this variable, and so what happens is that when this outer function is finished executing, then even then we still have the access to these variables because this function is using them, right? So later on, if we want to call this function func2, then we will be able to get these values a, b, c. And if we didn't have this inner function like this, then what would happen is that once this function was finished executing, then all these variables, all the stuff declared inside it, would be garbage collected, right? But in the case of Clojure, meaning when we define an inner function, then variables are not garbage collected. They are retained in the memory for long term. Alright, so that's a quick recap of Clojure. Now we will look at this advanced encapsulation. So what is encapsulation? It is a way to protect the internal state of a variable, and you can only access the variable using a certain method. Alright, so this is the definition, the standard definition, but let's first discuss why we need encapsulation. Why do we want to protect variables? For example, we have a variable called count equal to 0, a global variable, right? And over here we are accessing it, console log count. Alright, so normally, let's say we have written a script over here, and what it's doing is change the variable. It's incrementing count. Okay, and we have another script over here. Let me copy and paste it down below, and what it's doing is simply decrementing the count variable. Method name is 2. So let's say these functions are written in a file, and these in one file, and this stuff is written in another file. So if you're a programmer, you're working on a particular file and you are not aware of other files where these functions, these scripts are written, then yeah, you may be assuming that you're going to get the original value of count, right, which is 0. But that's not the case. Anyone can change this variable. Anyone can alter the state of this count variable because it's a global variable, right? It's a global one, and it's not within a function. It's not encapsulated, so it's a real risk, right? We have a risk of overriding variables. So in order to overcome this problem, we do what's called encapsulation. So in order to create encapsulation, we simply write the variables inside a function, right? For example, let's say we have a function create counter, and over here we have let count equals to 0, right? So this variable is now bound to this function. I mean, nobody will be able to access it without invoking this function. But there's a problem. Like we will either have to return this variable, meaning nobody will be able to even access it or do any modifications. So why we need Clojure? We need Clojure because we want to modify the variable outside of the function, right? So here comes the another part of the definition, which says you can only access the variable using a certain method, meaning it's not allowed to access or modify variables, but some certain methods are given, and using them you can definitely access or modify them. So it's a more strict way to and you can protect the variable, especially the internal state of the variable, right? So for example, I write a function change, and here I return change this function. That's how we define a closure, right? A function inside a function. And here I can simply do count plus plus, right? And over here I can say my func equals to create counter, and I can do my func. I can call my func, meaning I will be calling change, this function change, right? And by calling this function I will be simply incrementing the value of this variable like this. I can console log my fun, call it, and let's see the output. It's undefined. What happened? Create counter, and it's returning change. Okay. Is something running above? No, it's not. Let's simply print my func. It's a function change, alright. And when we call it, okay, we have to write a return statement over here, count. So when we call my function, we get the value 1. And if we do this twice, thrice, 4 times, then the value will be incremented. You mean the original value will be preserved, and based on the previous value, we will get the output. If it's 1, then 2, 3, 4, and so on and so forth, right? So now you get the idea, right? So in order to access this variable, we need to create a function. We need to call this function the outer function, and then we have to call the inner function, right? And this way we can modify it. So here we can write accessing the private variable, and this is the private variable. Okay, so that's about encapsulation. Let's look at a more complex example of it. Let me create a function, create counter as usual, and I will write count, initializing it to 0, and I will return an object here instead of a function. And this object will have 2 functions. One would be increment, and we simply do count plus plus and return count. Second one would be decrement. It will do count minus 1 and return count. Alright, and then we can also do reset. Count equal to 0 and return count. Right. So this way we are modifying the variable count, which is bound to this function, meaning it's encapsulated within this function. And in order to access this variable, we need to use these certain methods, increment, decrement. We need to use these methods, these public methods, right? So variable is private. Let me write private variable, encapsulated, and these are public method. Private variables means it cannot be accessed outside the function unless we invoke these public methods. That's what the definition is, right? You can only access the variable using a certain method, right? Down here we can do const my counter equal to create counter, and I can simply do my counter dot increment. We can get the output 1. Alright, if we do it thrice, let's say, then it will be 1, 2, 3. It makes sense. And now if we do decrement, then it will be 1, 2, 3, and 2. And over here we can also do reset. Resetting the value back to 0. It will be 1, 2, 3, 2, 0, right? So here we can write accessing the private variable count, right? This is how we are accessing the variable, and this is how we are encapsulating it, meaning we are declaring the variable simply inside a function. That's what encapsulation is called about, right? So in return statement we are defining some functions, and these are public methods. Using these methods, we can access and modify the variable count, right? So that's all there is to know about encapsulation. If you have any doubts, you can let me know in the comment section below.